Everyone, it is 6 p.m. and it's time for the Server Room Show. This is episode 17. I would like to thank you for everyone who tuned in today and also the people who listens to this in a form of a recording. As this is live, all the blobs and errors are left in, no cuts, no buts, it is raw material. This new show is streamed live at Unknown radio station every Saturday at 6 p.m. UTC time. There is a voice over IP phone line active during the show. You can call it either from a regular phone or via SIP. The number is +1 910 665 9191. The SIP account to call in at is 261 414 at San Jose 2, as in the number 2, .voip.ms. Today's topic is Unix. I would like to say that this episode of today is already up in Twitch TV as a live feed, so the people who want to enjoy the audio with the video feed of the desktop and myself, they can go to Twitch TV. The link for it is I left it in Mastodon and also in com, so you can pick it up and look at it from there, or you just put twitch.tv/Victor Madaras, which is my name, and the feed would come up. So finally it seems that it can become a bit more interactive than usual. The audio under both feeds are exactly the same, it's just being split, so the live stream can also take advantage of the same audio, and you guys listening to this in a form of a radio or a podcast getting exactly the same audio, so there is no difference except the video itself. I know there are some people who are making it the first time to be able to listen to this show. There has been already 17 episodes, and I would like to say that while we have some episodes like this one where for example, like the ones we made on Linux or virtualization or the routers or networking, while they don't carry any deep technical knowledge or information, the mission is to build with the help of these so to call more simple episodes, to build kind of like a common ground or some basic and general knowledge upon which further discussions and topics can be built and referred to, pretty much like a framework or like a foundation. So as I mentioned, today's topic is Unix. Again, an episode which is a bit more simple in its nature, but as I just referred to, it's fundamental and serves as a foundation or framework. We previously talked about Linux in previous episodes, and we cannot go forward without mentioning Unix, which is indeed inspired and had a fundamental impact on Linux, as well as on many other Unix-like operating systems, the ones we know and use today, as we will see in a short while. So what is Unix? Unix on its own, it is not one single thing or one single operating system. It is a family of multitasking, multi-user computer operating systems which derived from the original AT&T Unix department starting in the 1970s at Bell Labs Research Center by Ken Thompson, Dennis Ritchie and others. Initially intended for use inside the Bell systems, AT&T licensed Unix to outside parties in the late 1970s, leading to a variety of both academic and commercial Unix variants from vendors including University of California, Berkeley, which they normally just say BSD, Microsoft did Xenix, IBM did AIX, and Sun Microsystem Solaris, and Berkeley, as we said, did BSD. In the early 1990s, AT&T sold its rights in Unix to Novell, which then sold its Unix business to the Santa Cruz Operation, SCO, in 1995. The Unix trademark passed to the Open Group, a neutral industry consortium, which allows the use of the mark for certified operating system that comply with the single Unix specification. Unix systems are characterized by a modular design that is sometimes called the Unix philosophy. The operating system provides a set of simple tools that each performs a limited, well-defined function with a unified file system, the Unix file system, as the main means of communication, and the shell scripting and command language, the Unix shell, to combine the tools to perform complex workflows. Unix distinguishes itself from its predecessors as the first portable operating system. Almost the entire operating system is written in the C programming language, thus allowing Unix to reach numerous platforms. In a form of a short overview, Unix was originally meant to be a convenient platform for programmers developing software to be run on it and on other systems, rather than for non-programmers. The system grew larger as the operating system started spreading in academic circles, and as users added their own tools to the system and shared them with colleagues. At first, Unix was not designed to be portable or for multitasking. Later, Unix gradually gained portability, multitasking, and multi-user capabilities in a time-sharing configuration. Unix systems are characterized by various concepts: the use of plain text for storing data, a hierarchical file system, treating devices and certain types of inter-process communication as files, and the use of a large number of software tools, small programs that can be strung together through a command line interpreter using pipes, as opposed to using a single monolithic program that includes all of the same functionality. These concepts are collectively known as the Unix philosophy. Brian Kenningen and Rob Pike summarize this as the Unix programming environment, as the idea that the power of a system comes more from the relationships among programs than from the programs themselves. Pretty much how well the individual applications can be tied together and work together, rather than one single individual program itself. Important is how well they can work together and become more than just how good they could be on their own. In an era when a standard computer consisted of a hard disk for storage and a data terminal for input and output, the Unix file model worked quite well, as I/O was generally linear. In the 1980s, non-blocking I/O and a set of inter-process communication mechanisms were augmented with Unix domain sockets, shared memory, message queues, and semaphores, as well as network sockets to support communication with other hosts. As a graphical user interface is developed, the file model proved inadequate to the task of handling asynchronous events such as those generated by the mouse. By the early 1980s, users began seeing Unix as a potential universal operating system suitable for computers of all sizes. The Unix environment and the client-server program model were essential elements in the development of the Internet of the reshaping computing as centered in networks rather than in individual computers. Both Unix and the C programming language were developed by AT&T and distributed to government and academic institutions, which led to both being ported to a wider variety of machine families than any other operating system. The Unix operating system consists of many libraries and utilities along with the master control program, the kernel. The kernel provides services to start and stop programs, handles the file system and other common low-level tasks that most programs share, and schedules access to avoid conflicts when programs try to access the same resource or device simultaneously. To mediate such access, the kernel has special rights reflected in the distinction of kernel space from user space, the latter being a priority realm where most application programs operate. If you remember, this is exactly the same regarding the kernel and the kernel space and user space separation, exactly the same when we discussed in a previous episode about Linux. So you can see where Linux took that approach or idea from. Let's see the history of Unix. The origins of Unix date back to the mid-1960s, when the Massachusetts Institute of Technology, Bell Labs and General Electric were developing Multics, a time-sharing operating system for the GE 645 mainframe computer. Multics featured several innovations, but also presented several problems, severe problems. Frustrated by the size and complexity of Multics, but not by its goals, individual researchers at Bell Labs started withdrawing from the project. The last to leave were Ken Thompson, Dennis Ritchie, Douglas McElroy, and Joe Osana, who decided to re-implement their experiences in a new project of smaller scale. This new operating system was initially without organizational backing and also without a name. The new operating system was a single tasking system. In 1970, the group coined the name Unix, UNICS, for Uniplexed Information and Computing Service, pronounced Unix, EUNUX, as a pun on Multics, which stood for Multiplexed Information and Computer Services. Brian Kanigan takes credit for the idea, but adds that no one can remember the origin of the final spelling Unix as UNIX. Dennis Ritchie, Doug McElroy, and Peter G. Neumann also credit Kernighan for the idea. The operating system was originally written in assembly language, but in 1973, version 4 Unix was rewritten in C. However, still had many PDP-11 dependent codes and was not suitable for porting, for transporting or moving it to another computer. The first port to another platform was made 5 years later in 1978 for an Interdata 8/32. Bell Labs produced several versions of Unix that are collectively referred to as Research Unix. In 1975, the first source license for Unix was sold to Donald B. Gillies at the University of Illinois at Urbana-Champaign Department of Computer Science. UIUC graduate student Greg Chesson, who had worked on the Unix kernel at Bell Labs, was instrumental in negotiating the terms of the license. During the late 1970s and early 1980s, the influence of Unix in academic circles led to large-scale adoption of Unix, BSD and System 5 by commercial startups including Sequent, HPUX, Solaris, AIX and Xenix. In the late 1980s, AT&T Unix System Laboratories and Sun Microsystems developed System 5 Relix 4, SVR4, which was subsequently adopted by many commercial Unix vendors. In the 1990s, Unix and Unix-like systems grew in popularity as BSD and Linux distributions were developed through collaboration by a worldwide network of programmers. In 2000, Apple released Darwin, also a Unix system, which became the core of the Mac OS X operating system, which was later renamed Mac OS. Unix operating systems are widely used in modern servers, workstations, and mobile devices. Let's talk about some standards. namely as POSIX. In the late 1980s, an open operating system standardization effort, now known as POSIX, provided a common baseline for all operating systems. IEEE based POSIX around the common structure of the major competing variants of the Unix system, publishing the first POSIX standard in 1988. In the early 1990s, a separate but very similar effort was started by an industry consortium, the Common Open Software Environment Initiative, which eventually became the single Unix specification. Starting in 1998, the Open Group and the IEEE started the Austin Group to provide a common definition of POSIX and a single Unix specification, which by 2008 had become the Open Group-based specification. In 1999, in an effort towards compatibility, several Unix system vendors agreed on SVR4's executable and linkable format, ELF, as the standard for binary and object code files. The common format allows substantial binary compatibility among different Unix systems operating on the same CPU architecture. The file system hierarchy standard was created to provide a reference directory layout for Unix-like operating systems. It has mainly been used in Linux. Let's talk about the impact. The Unix system had a significant impact on other operating systems. It achieved its reputation by its interactivity, by providing the software at a nominal fee for educational use, by running on inexpensive hardware, and by easy to adopt and move to different machines. Unix was originally written in assembly language, but was soon rewritten in C, high-level programming language. Although this followed the lead of Multics and Burroughs, it was Unix that popularized the idea. Unix had a drastically simplified file model compared to many contemporary operating systems, treating all kinds of files as simple byte arrays. The file system hierarchy contained machine services and devices, such as printers, terminals, or disk drives, providing a uniform interface, but at the expense of occasionally requiring additional mechanisms such as IOCTL and the mode flags to access features of the hardware that did not fit the simple stream of bytes model. The Plan 9 operating system pushed this model even further and eliminated the need for additional mechanisms. Unix also popularized the hierarchical file system with arbitrarily nested subdirectories, originally introduced by Multics. Other common operating systems of the era had ways to divide a storage device into multiple directories or sections, but they had a fixed number of levels, often only one level. Several major proprietary operating systems eventually added recursive subdirectory capabilities, also patterned after Multics. DEX RSX11M group user hierarchy evolved into VMS directories. CP/M's volumes evolved into MS-DOS 2.0 plus subdirectories, and HP's MPE group account hierarchy and IBM's SSP and OS400 library systems were folded into broader POSIX file systems, making the command interpreter an ordinary user-level program with additional commands provided as separate programs was another Multics innovation popularized by Unix. The Unix shell used the same language for interactive commands as for scripting. Shell scripts, there was no separate job control language like IBM's GCL on the mainframes. Since the shell and OS commands were just another program, the user could choose or even write their own shell. New commands could be added without changing the shell itself. Unix innovative command line syntax for creating modular chains of producer-consumer process pipelines made a powerful programming paradigm, coroutines, widely available. Many later command line interpreters have been inspired by the Unix shell. A fundamental simplifying assumption of Unix was its focus on new line delimited text for nearly all file formats. There were no binary editors in the original version of Unix. The entire system was configured using textual shell command scripts. The common denominator in the I/O system was the byte, unlike record-based file systems. Like mainframes are record-based, I think. The focus on text for representing nearly everything made Unix pipes especially useful, encouraged the development of simple general tools that could be easily combined to perform more complicated ad hoc tasks. The focus on text and bytes made the system far more scalable and portable than other systems. Over time, text-based applications have also proven popular in application areas such as printing languages, POSIX or ODF, and at the application layer of the Internet protocols like FTP, SMTP, HTTP, SOAP, and SIP. Unix popularized syntax for regular expressions that found widespread use. The Unix programming interface became the basis for a widely implemented operating system interface standard, the POSIX we talked above. The C programming language soon spread beyond Unix, and it's now ubiquitous in systems and applications programming. Early Unix developers were important in bringing the concepts of modularity and reusability into software engineering practice, spawning a software tools movement. Over time, the leading developers of Unix and programs that ran on it established a set of cultural norms for developing software, norms which became as important and influential as the technology of Unix itself. This has been termed the Unix philosophy. The TCP/IP networking protocols were quickly implemented on the Unix versions, widely used on relatively inexpensive computers, which contributed to the internet explosion of worldwide real-time connectivity and which formed the basis for implementations on many other platforms. The Unix policy of extensive online documentation and for many years ready access to all system source code raised programmer expectations and contributed to the launch of the free software movement in 1983. Free Unix and Unix-like variants. In 1983, Richard Stallman announced the GNU, short for GNU's Not Unix project, an ambitious effort to create a free software Unix-like system, free in the sense that everyone who received a copy would be free to use, study, modify, and redistribute it. The GNU project's own kernel development project, GNU Herd, had not yet produced a working kernel, but in 1991 Linux Store was released the kernel Linux as free software under the GNU General Public License. In addition to their use in the GNU operating system, many GNU packages such as the GNU compiler collection and the rest of the GNU toolchain, the GNU C library and the GNU core utilities have gone on to play central roles in other free Unix systems as well. Linux distributions consisting of the Linux kernel and the large collections of compatible software have become popular both with individual users and in businesses. Popular distributions include Red Hat Enterprise Linux, Fedora, SUSE Linux Enterprise, OpenSUSE, Debian, GNU Linux, Ubuntu, Linux Mint, Mandriva, Slackware Linux, Arch Linux, Gentoo, many. A free derivative of BSD Unix 386 BSD was released in 1992 and led to the NetBSD and FreeBSD projects. Because anyway, people will say that we don't love BSD, but we do love. Sometimes we love BSD more than Linux and vice versa, but best to have both. I like both with their things. BSD is very cool and Linux is very good also. With the 1994 settlement of a lawsuit brought against the University of California and Berkeley Software Design by Unix System Laboratories, it was clarified that Berkeley had the right to distribute BSD Unix for free if it so desired. Since then, BSD Unix has been developed in several different product branches, including OpenBSD and Dragonfly BSD. Linux and BSD are increasingly filling the market needs traditionally served by proprietary Unix operating systems, as well as expanding into new markets such as the consumer desktop and mobile and embedded devices. Because of the modular design of the Unix model, sharing components is relatively common. Consequently, most or all Unix and Unix-like systems include at least some BSD code, and some systems also include GNU utilities in their distributions. In 1999 interview, Dennis Ritchie voiced his opinion that Linux and BSD operating systems are a continuation of the basis of the Unix design and are derivatives of Unix. I have to agree. I think that both Linux and BSD are somehow the continuation and derived or inspired from Unix. Somehow I always feel or felt like that BSD systems were somehow more the true and hardcore continuation of Unix, while Linux was not so much to say. Somehow that's why I love BSD more when I want to dig deep down to something really Unix, I would say Unix-like, but something true to the original Unix, something true to the original Unix. I normally go to some BSD systems, and when I don't need something as hardcore and true to its roots, I stick with Linux normally. The Linux phenomenon is quite delightful because it draws so strongly on the basis that Unix provided. Linux seems to be among the healthiest of the direct Unix derivatives, although there are also the various BSD systems as well as the more official offerings from the workstation and mainframe manufacturers. Also, OpenSolaris was the open source counterpart to Solaris developed by Sun Microsystems, which included CDDL licensed kernel and primary GNU userland. However, Oracle discontinued the project upon the requisition of Sun, which prompted a group of former Sun employees and members of the OpenSolaris community to fork OpenSolaris into the Illumos kernel. And since 2014, Illumos remains the only active open source System 5 derivative still alive. Our time is soon gonna be finished. I left some actually I left a video about Unix from the AT&T archives about the Unix operating systems. A video, it's quite nice and explanatory, and also evolution of Unix and Unix-like systems, which is like a chart of which got derived from what, and actually it would explain why I feel BSD and its derivatives are more true to the hardcore Unix roots than Linux is. It doesn't want to say neither one is better than the other nor anything like that. It's just you look at the chart and probably you get the same idea. So our time is up, and for next week we have a heavier topic, which is not so foundation type like this one. It's gonna be Docker and Kubernetes, if we can do the two together. If not, then we will make a part 1 and a part 2. Thank you for everyone for listening, and see you next Saturday.